Hello and welcome. I'm your host, Adam Hawkins. In each episode, I present a small batch of the theory and practices behind building a high-velocity software organization. Topics include DevOps, Lean, software architecture, continuous delivery, and conversations with industry leaders. Now, let's begin today's episode. Aloha, everyone. Adam here, coming to you from sunny and warm Hawaii, right in the middle of the Pacific Ocean. I have a few things to share with you today before we get into today's episode. I've updated all the free resources I've made to support the show. You may have already seen some of these, but if you haven't, then they've got a shiny new coat of paint. The first is my Project to Product email course. You've heard me talk about the book and the flow framework on this podcast, and even an interview with Mick Kirsten to dive deeper into it. This email course goes deeper than we could in these episodes and covers parts we've not touched on so far. My favorite parts are the 3 epiphanies and the turning point into the age of software. Both are key points to the high-level thesis that haven't appeared on the show. You can get this one at projecttoproductsummary.com. Second is my continuous improvement pocket guide. This is really the third way of DevOps as described through Mike Rother's Toyota Kata book. The pocket guide covers the connection between DevOps and Toyota, a shareable 5-point summary, and tips on bootstrapping the improvement and coaching katas. So, if you're feeling stuck in the status quo, then topple it with the Toyota Kata. Get this one at toyotakatapocketguide.com. Third is my War and Peace in IT pocket guide. You could spend a week reading through why IT fails to deliver on time, complete, and on-budget projects, and then continue on why hypothesis-driven thinking, lean theory, and DevOps offer a way forward. Or you could just spend 20 minutes with me and only get the best bits. It's like a small batches episode for a book. Get this one at warpeaceanditpocketguide.com. All 3 of these are free. Now, I also got to give a shout out to my flagship DevOps course. It combines the best of the DevOps Handbook, Accelerate with years of my practical software delivery experience. Get the free 9-day email course at freedevopscourse.com. If you just started listening to this podcast, then this is a great place to start. It goes much deeper into the topics that I'm able to cover on this podcast. Lastly, there's something new I'm trying to put together for February or March 2021. I'm running a 4-week software delivery dojo. Participants will meet each Sunday for practical and theoretical exercises related to software delivery. The point of this dojo is to level up people's skills in building, deploying, and operating production systems. This is really an experiment for me, so I'm not entirely sure what we'll cover, but it's more participant-driven at the moment. I'm offering this at an amazingly affordable price to listeners of this podcast and members of my list. Spots are limited, so apply now at softwaredeliverydojo.com. Of course, you can find links to all of these on the show notes page at smallbatches.fm. Now, let me introduce today's guest. Today, I'm speaking with Viktor Farcic. Viktor is a Principal DevOps Architect at CodeFresh. He's a member of the Google Developer Experts, Continuous Delivery Foundation Ambassadors, and even Docker Captains Group, and also a published author. His big passions are DevOps, containers, Kubernetes, microservices, continuous integration, delivery, deployment pipelines, and test-driven development. Really sounds a bit like me, right? He's also published the DevOps Toolkit series of books and videos, and the test-driven Java development book, as well as numerous courses on Udemy. He's also the co-host of the DevOps Paradox podcast, which I recently appeared on. That was a fun episode discussing a day in the life of an SRE. Link to that one in the show notes too. As I mentioned, Viktor is a Principal DevOps Architect at CodeFresh, which I am a big fan of. Recently, I did a webinar on building extendable and composable deployment pipelines using CodeFresh. This was an official collaboration between Skillshare and CodeFresh, so if you're curious about how I think about and build pipelines, then check out that webinar. The recording is linked in the show notes too. So I'm stoked to talk to Viktor because he has such a wide range of experience, plus he's really just a fun guy to talk to. I think that really comes out in this interview, and I don't think I've laughed so hard while talking tech in a long time. Anyway, Viktor and I discuss the GitOps workflow, how and why to use ArgoCD, but we don't really go too deep into the technical specifics. Instead, we focus on how these tools fit into the deployment pipeline and help teams achieve fast flow. So I give you my conversation with Viktor Farcic. Victor, welcome to the show.
Thank you for having me.
My pleasure. I'm more than happy to talk to you today. It's actually a kind of a special episode of Small Batches in a way, because I think this will be the first episode that we talk about a specific technology. Typically on the podcast, we talk more about like high-level theory and practices rather than implementing with specific technology. So I'm happy to have you on today to talk about ArgoCD and GitOps. So maybe we can start just at the basics and level up from there. Can you explain what is GitOps and what is ArgoCD?
GitOps, I can explain it as a set of principles that start with the idea that everything is defined as code. And from there on, we can follow that line of thought. If everything is code, everything is in Git. If everything is in Git, Git defines the desired state, what we want. And then we have some processes automated, hopefully, that are converging the actual state, what is happening in your clusters, or even what your clusters are, into that desired state. I think that kind of, if we go further away from the definition, we would just enter into specific use cases. But that should cover, I think, whole GitOps.
Yeah. So, okay. I think that some of the sort of expectation around GitOps with this, at least in my experience, is it kind of comes down to like, hey, everything is YAML. If you don't have YAML, then it's sort of like weird, it doesn't fit. But in your opinion, how does other infrastructure as code or declarative type things like Terraform and all of that fit into GitOps?
I think that fits perfectly. And I don't believe that everything should be YAML now. Maybe it should be 90% or 20%, right? But you just mentioned Terraform. Terraform is probably the best tool we have today to manage infrastructure. It is not in YAML. It's in, I think it's called HCL. And that's okay, right? And many other things might or might not be in YAML. I would rather say that it's very helpful if that something is defined in a declarative format.
Mm-hmm.
Because it's much easier to define the state of something in a declarative format than imperative, right? Now, hey, if you want to use JSON, that works just as well. If you want XML, I feel sorry for you, but still that works just as well, right?
Yeah.
It's not really about that it has to be YAML. Doesn't. It just happens to be the most popular today.
Yeah. Well, I think the key point of the definition is that it's declarative code. Like the format doesn't necessarily matter. It's JSON, YAML, HCL, whatever you want to call it. But you pass this to some other program, it analyzes the state of the world, and then makes the declared state into reality, right?
Yeah. I mean, theoretically, it could be some imperative format as well, but then we would really do this favor to machines who need to converge that, right? Because for machines, reading something defined in declarative format makes it so much easier to figure out, what are the differences, what is missing, what is different, and so on and so forth.
Mm-hmm.
It's not necessarily even that it has to be declarative. It's just so much easier.
Mm-hmm.
And I think that almost all the tools that are of that type, right, that defines the state of something that were not based on declarative format are probably gone, right? There aren't many left.
Mm-hmm. Just a quick sidebar into this discussion, but where does something like Ansible fall into this in your mind?
I mean, depends how you define the question. I think that from GitOps perspective, yes. I mean, Ansible defines the state of your infrastructure or even of your applications. And from GitOps perspective, yes, that's just as valid as anything else. Now, I have a personal grudge with Ansible.
Ooh, do tell.
So what I think is, I think that Ansible and the predecessors of Ansible, like Chef, Puppet, and CF Engine, if whomever doesn't know what CF Engine means will make me depressed because that means that I'm old. But I think that all those tools are based on promise theory and were really designed with mutable logic, right? Mutable infrastructure, mutable deployments. Now, I know full well that Ansible can work with immutable stuff, right? But it's not really designed for that. I don't think it's just as good fit for immutable world as, let's say, Terraform Or even it could be Pulumi. And now we are already entering into the domain of it doesn't even have to be declarative, right?
Exactly.
So it doesn't. To be honest, actually, there is no such thing as pure declarative or pure imperative either. I can find just as many examples in Terraform definitions where when you had to do some loops and some if statements and or not, right?
Oh, yeah.
So it's more like, it's more declarative than not, or the other way around, right?
Right. You spend more time describing what you want rather than how to do it.
Yeah. And that this conversation, I think, leads us to not a rule, not a requirement, but a nice to have thing about GitOps, and that is everything being immutable. Doesn't have to be.
But it certainly helps.
But it really simplifies. Helps a lot.
Yeah.
And I have this feeling that people are still having trouble wrapping their heads around immutable world. Somehow with applications, we are all got used to images being converted into containers, hopefully not doing any funky stuff once that becomes a container. But with infrastructure still, when I tell people you never upgrade anything inside VM or you never update your VM, sometimes they still look at me kind of, oh, what is this guy? What do you mean?
Oh,
how can that be? No?
Yeah, I get where you're coming from. And I think this is something that I also encounter in just like my own talking to people. It's hard for me to like understand or just like always remember that like there's some people who have never even heard of the concept of infrastructure as code or immutable infrastructure. You know, like some of these things that we take for granted that they're just assumed that people never heard of them. And, you know, if you tell somebody, hey, you never update your VM or update anything inside an image, well, that's true. But if you need to update something, you just create a new image. You still do that. It's just that how it happens is different. And I agree with you in that Ansible and some of these tools, like they predate the idea of immutable as principle zero, right? Like there's the idea of SSHing into machines, running some scripts and changing the special pets and making the world as you want is different than, hey, I create the whole world. And if I want to create a new world, I just change it, run this script or run this program and it built a new world for me. I can tear it down, recreate it, modify it, whatever I want. You don't care. There's no attachment to any of these things. They don't matter. You know, that opens up all kinds of extra use cases like, hey, you opened a branch. Oh, you can just take everything in this branch, deploy it to a preview environment, open the application, and then when you're done, tear it down. You can create test environments. You can do, you know, all kinds of stuff like that. So now to circle back to GitOps, this is, I think, where it's really useful. Because if you have your entire world or state or application, whatever you want to call that, defined in a code repository, then you can just pass this repository through your deployment pipeline. And at the end of the day, the desired state is the final state. So how does ArgoCD fit into this? Maybe you can explain what ArgoCD is.
Yeah, before that, let me just say very quickly that I hate the name. I dislike that it's called ArgoCD.
Oh, yeah?
Because I have a different definition of CD, what CD is.
Oh, good. I want to hear this one.
Okay. So the way to me, CD, continuous delivery, is about automating all the steps in life cycle of your application from the moment you commit it to Git until it is releasable to production, or released to production, then it's continuous deployment. More or less the same thing, right?
Yeah, you and I have the same definition.
Yeah, but then there is that, movement of people naming things randomly, and it's almost random, right? Because, okay, I'll get back to CD. Let me just, in one sentence, explain what ArgoCD does. ArgoCD is deploying applications based on definitions in Git.
Okay.
And now if I circle back to CD, that's not CD, right? That's, in my head at least, that's a fraction of what CD is.
Yeah.
Because I cannot deploy thin air. I need to build that something. I need to push it to registry. I need to test it, hopefully, and so on and so forth. So CD word out of the way. ArgoCD is, what it is really doing is monitoring Git repositories and making sure that the actual state on the application level is the same as the desired state stored in those Git repositories. So you can think of it almost as as if there are some gremlins that are running Helm install, Helm upgrade all the time, right? When I'm more looking at what's going on, oh, this changed. I should execute this command. I should execute this command. I should do whatever I need to do to make sure that the changes are applied. Either because I pushed the change to Git, or maybe I didn't push anything, but simply the state of the cluster for one reason or another changed, and it doesn't comply with my picture, of the desired state in Git. And so from that perspective, ArgoCD is almost the same as, let's say, running pipelines triggered by you making changes to code repository and then executing kubectl apply or whatever you would be using. And I think that the real essential difference between the two is in whether it's a push or a pull based model. So while traditionally we would intercept those changes, triggers of changes in Git repository, and then do this or that, either from my terminal maybe, or from CD pipeline, or from here or there, this is an entity running in a cluster and monitoring your Git repository. And that means that basically, theoretically, I know that it's never going to be like that 100% in practice, but theoretically, I could have my production without any incoming traffic, without people or other tools having my secrets, having access to my cluster, having any way of communicating with the cluster, and yet cluster always being in the state that I define. So many people I haven't heard that kind of being as a main description of ArgoCD, but from my perspective, that is the main difference, that pull model instead of a push model that most of us are using, right?
Yeah. So to just restate what you said to make sure I understand what you're saying, and that let's imagine one type of system where you could imagine some sort of deployment pipeline. One step, let's say you're deploying a Kubernetes-based application, would be like generate manifest and do something like kubectl apply in the pipeline. That's like a direct communication to the cluster. That's a push to the cluster, pushing new application to the cluster. And then in Argo, you have something running in the cluster that says, oh, I observed an external state change outside the cluster. Now I will do whatever is required inside the cluster. So that's a pull model. The same type of thing that you would see in other types of configuration management systems. Like if you're running something like Puppet or Chef, you have some agent running, it notices a change and applies it to everything. One question, this is just me not as familiar with ArgoCD as I maybe should be, but what types of applications can you deploy with ArgoCD? Is this a Kubernetes only thing, or is there something else?
Kubernetes only.
Okay.
In case of ArgoCD itself, it's only Kubernetes. Now, of course, we could apply the same logic outside Kubernetes, but
it's just easier inside Kubernetes because it already is effectively GitOps in the sense that you throw some YAML at the manifest, at the API or whatever, you make some API calls, and eventually Kubernetes does whatever to change all the desired state of everything that's there already, or creates updates as it sees fit.
Exactly. And, if I would be starting project of that type from scratch right now, I would do it Kubernetes only, at least until I earn a lot of money and I can hire 500 people, simply because we have one API to rule them all, right? It works in AWS, it works in Azure, it works on-prem, it works wherever Kubernetes is.
Yeah, which is everywhere.
Exactly. I mean, theoretically, you could have it even in IoT, right? ArgoCD doing stuff. Maybe not by running there, but.
Yeah, it's true. Okay, so technical question here. So let's say that I'm deploying an application with ArgoCD. And like me personally, I'm used to writing manifests, used to making Helm charts, writing all these things. So if I want to deploy with ArgoCD, am I writing Kubernetes manifest? Am I writing something else? Like, how exactly am I declaring these things?
No, that's, I think, one of the major difference between ArgoCD and probably the only other similar tool, which is Flux, is that ArgoCD is really, whichever way you're used to have your manifest, that continues working. The only difference between what you might be doing today and if you would adopt ArgoCD is that you have one more definition, which is a kind of definition would be application, ArgoCD application, which in its essence, the only thing that that application does in a simplified way is provides ArgoCD with the the URL of the repo that it should monitor, right? So once you create that ArgoCD application, and essentially you're telling it, hey, monitor this directory in this repository. From there on, it could be manifest as in any way you already have them right now. Now, to be honest, once you adopt ArgoCD, then you might start seeing some, and GitOps in general, you might start seeing some patterns which might compel you to change some of the things you do, but it's not mandatory, right? It's more like, hey, look I can do this, right?
Okay, so let's talk about that a little bit, because say if you're coming from sort of, hey, I saw this new technology, I think it will help me, it changes the workflow. I have to think differently. So you mentioned some patterns. So what are the kind of like day two realizations when you adopt a workflow like this?
So what I normally do is I would create what we call application of applications in ArgoCD. So application would be, here's the repository of my production, right? Now, traditionally, that would mean that in the production repository, I would have all the definitions like Helm charts or Kubernetes YAML files or what's not. But what normally we would do is in that repository of production, instead of copying and pasting all the files all over the place, in staging production, I would have just a single application. Application A point to the repository of application A and potentially maybe overwrite those values, like number of replicas or what's not. So my production repository would be a collection of ArgoCD applications instead of traditional definitions. And that would be just few lines, right? Hey, application A is there, overwrite those values. Application B is over there, overwrite those values, etc., etc. And then you would have maybe staging repository or a branch, doesn't matter, which would apply the same method, but pointing to same applications, but maybe different tags, right? So that's kind of one of the changes that you might not want to keep copying files all over the place, because assuming that you have multiple environments, right?
Okay, I see. So if I understand what you're saying, if you kind of imagine, say, like a Helm-based deployment system, you might have, say, a values file for each of the environments that you deploy to. And say, if you get into this GitOps and more declarative state workflow, instead of having multiple files where you say like, hey, there's code plus configuration, and that means development or staging or production. And what you're saying is it could make more sense to have, say, one repo that's just application, whatever you want to call it, but that inside that there's a branch for staging or a branch for production or different repos or whatever, that instead of modeling your environments as different configuration files, kind of think of them as different branches or repositories that allow you to group all the different things that compose that environment. Is that what you're talking about?
Exactly. So one environment is a repository or a branch in a repository that provides two things: the links to where the original definitions of applications are, right? Usually links to repositories of those applications and whatever you want to overwrite. So that Helm values file variations, I would probably not keep them in the repository of the application itself, but in that repository that defines the environment. That allows me to go, because it's very powerful being able to say, hey, I go to this repository and I can find out everything I need to know about the desired state of my production, let's say. Instead of going, hey, yeah, this file in the repository of application A plus this file of repository application B, and like you go running around like chicken without head until you figure out what it is.
If you can even figure out all the things that actually are part of that environment. I think, which is a segue into the next set of topics I wanted to discuss with you. But first, I want to follow up on this point, which is one thing that I've always struggled with is that, and this is a problem that gets worse as you move towards more services and try to adopt things like microservices, is that, okay, yes, on one hand, we have the ideal that, teams should be able to work independently, have ownership and autonomy all over their bit of code that they're responsible for. They can build it, deploy it, run it in production, all that. Now, that's great for that team who is, purely concerned with that little slice of the application or product service, however you want to define it. And then there's the other set of people. These people tend to be like myself, who are operating either at like a lower level in the platform, at a higher level in the service, that say, okay, well, now I have an environment that I need to have service, like all these different applications or services like service A, service B, and service C, so I can create an environment that I can test out the product or test out some infrastructure. And when you have, 10 or 20 or 100 different microservices all spread out across, X number of code bases, what actually represents a production environment? Whereas like with the approach I think you're talking about here, you can just say, oh, it is the production folder in this repository, or this file in this, that lists out the config or declares everything for all of the things that actually compose all of the environments, which I think is probably one of the key differentiators or like benefits of this type of approach, is you can really reference all the different parts of your system in this one way.
It's like treating your production or staging or whatever as if it is an application as well, as if it's Uber application, right?
Yeah.
And just like normal applications are not only the code of that application, they have libraries that they fetch from different places, and then they are parameterized and with different values and what's or not. Same thing for an environment, right? The environment is a collection of applications, just like application is a collection of libraries plus custom code, right? And it's a similar approach, I believe. And if you go back to that autonomy, of those teams, in most cases, that becomes irrelevant for them, because I don't want anybody to go and start manually changing repository of production. And then you say, oh, I need to have autonomy to all. No, I mean, that's all part of some process. You say, hey, I want to promote this release to production. Maybe I give you a button. Maybe I give you a script. No matter what I give you, that button, script, or whatever will make some changes to Git repository. ArgoCD or whatever else you might be using will converge that change into the actual state. So for most people, that is transparent. That is simply something happening in the background. But for people who do care about what is in production, let me rephrase. Not what is in production. What is in production you see by looking at the cluster itself. But there are people who might want to know what should be in production. Sounds like semantical difference, but actually it is a huge difference, what should be and what is.
Yeah. Okay. So one other question I have here is, let's imagine you're working with this sort of like GitOps workflow, and you have this repository that's like, hey, this is what production is. What I'm imagining in that repository is some configuration of applications. This might be like, Docker images, Helm charts, whatever, and then some version. It could be a commit SHA, it could be a semantic version, it could be whatever. So let's say that I'm working on application A and I want to release application A. Given that we're talking about, a source code or Git-driven workflow, then I would go to this production repository, make a change to the version of application A that should be running and commit that, and then let the declarative stuff do its business, right?
Yes, except that you shouldn't be doing that. I think that this is where our perception, and going to the very beginning of this conversation, this is where our perception of the roles of CD or CI or whatever you want to call it, pipelines are changing, right? Mm-hmm. You would have a pipeline so let's say that simplified workflow, right? You create a pull request. When your pull request is created, it is deployed somewhere. You run some tests, whatever. You merge pull request to master, and then it goes to production. Simplified version, right?
Yeah.
Now, what that means from process perspective, from pipelines perspective, is that when I create a pull request, it should build, it should do this or that, and at one moment it should go to, let's call it pull request environments repo. It should go there and add, hey, you should create a unique namespace based on maybe a pull request ID or whatever, and deploy this application, right? It should make that change to Git repository, and that's done by a pipeline, right?
Yeah.
And then pipeline would maybe receive a signal back from, let's say, ArgoCD, hey, I'm finished. And then pipeline continues and runs your tests or whatever. And then you merge that pull request to the master branch. That similar pipeline would remove that pull request based application because you don't need it anymore. But then it would go to your production repository. It says, hey, you know that YAML file over there that among other things has the tag, Helm value, let's say, change the tag to this.
Yeah,
I know what the tag is. I just built it, right? There is no need for you to tell me what the tag is. I just built it, right? So just pass that information and make a change to Git.
Yeah.
And that's not that different from what we were doing before, except that pipeline is not touching your cluster. For pipeline, there is no cluster, there is Git repository, right? And it just fetches information from there, changes information. Maybe it would create a pull request to the production repository instead of changing directly the tag and wait for you to merge that pull request, right? There are different patterns.
Yeah. So for the listener there, if you're adopting this type of workflow, instead of learning to, script and program around kubectl, time to get really good at programming with Git. Is you, instead of making these changes directly with Git commits or doing it yourself, you will have a script that says, open a PR, make the change to this file. This is where things like YQ and JQ and all of these sort of text manipulation and, parsing things come into play because, like as you said, humans need not do this and should not do this. It's all about making machines do all the work for us. So just a way of like changing your thinking in the sense of, hey, what you're going to be automating and putting into the pipeline is not state management or infrastructure management, cluster management. It's going to be commits, changes to Git instead of changes to infrastructure or something else, right?
It's I think it's, at least from my perspective, I think that people also themselves have trouble to rewire their brain to that declarative type of thinking, which is very strange because we are declarative most of the time outside of software industry. Like if you go to a restaurant, right, you say, can I have a burger with cheese and bacon, right? That's what you say.
Yeah.
And now if we would translate that experience to what we traditionally do in software industry, we would say, hey, can you go outside, find a cow, take a bit of meat from that cow, let it dry for a while, and then, and put a bit of oil. No, we don't do that, right? In real life, we are declarative most of the time. We express our desires. We don't give commands unless you're, I don't know, in military maybe.
Yeah.
And it's that type of thinking. I'm just expressing what I want. Go figure it out.
Well, one other, I think, benefit from this approach is thinking in async by default in terms of pipelines, because eventually something has become async in that process, because you do want a pipeline that says, I made a change to this application, deploy it to some pre-production environment. That's going to take, who knows how much time. It could take 5 minutes, it could take an hour, you don't know. Point is, it's going to take a long time. It could fail or succeed for any number of reasons. And then you need to listen for that, move through the next stages of whatever kind of asyncness that could happen. But if you think in like an async model of the pipeline by default, you open up a whole bunch of other use cases than if you were thinking and assumed that everything was going to be synchronous by design.
There's a recent story from within my company. We are discussing how we can, since I work for CodeFresh, we do pipelines, some other things, but in this context, pipelines are what matters. We're discussing how we can marry pipelines and GitOps, right? And then some people with the best possible intentions can come to the conclusion that, hey, we need to provide in pipelines mechanism for a pipeline to send a sync command to ArgoCD, wait until ArgoCD is finished doing whatever it's doing so that pipeline can continue and maybe run tests only after your application is up and running.
Mm-hmm.
And that was the moment where I freaked out. No, you don't do that. You push to Git, we already established that, and then you do nothing. Then you wait until ArgoCD comes back to you and says, I'm done. You don't wait and say, are you done? Are you done? Are you done? Are you done? Are you done?
Right.
Yes, okay. And then you continue. No. You just create a mechanism to listen to events. Everybody listens to somebody's events. Hey, it will tell you when it's done.
Yeah. It's like push and then pull, push and then pull. Like you, instead of thinking, sure, you can think conceptually as my pipeline from commit to production is one pipeline, but that need not be technically implemented as one pipeline. There could be any number of steps that could execute in parallel. They could execute not in parallel. They have a sequence. There's all kinds of different sub-pipelines that give you everything you need to say that, hey, one change is ready to go to production, right?
Correct.
Okay, so then now let's move into the next topic. We got a little sidetracked there, but I think it was good stuff to mention, which is I want to bring this back to the 3 ways of DevOps and why should we care about technologies like this? So like what I talk about on small batches is the idea of improving velocity, increasing reliability, and building higher quality software, and doing all of that faster. So the first way of DevOps flow is about optimizing to improve the speed from development to production, right? So continuous delivery, automated deployments is all part of that. And then the second way of DevOps, feedback, which is providing feedback from production back into development, right? So if you see that something is not working in production, you have the appropriate telemetry to notice that, either do like an automated rollback or whatever, but to learn from that and then make sure that those same negative outcomes are not repeated. And then we have the third way of DevOps, which is learning, sort of, if you can imagine this as sort of an inner feedback loop. So you get this nice cycle going from development to production, and then production back to development, and then an outer feedback loop that is continually trying to learn and optimize all the processes that make all those other things happen. So why should we care about these technologies or this way of working? Like, how does it make a difference in those areas?
So I think that the second one is problematic, at least from GitOps perspective. I'll get to that.
Mm-hmm.
But flow and learning, to begin with, enforcing the idea that everything is in Git is potentially, generally speaking, the easiest way we have today to enforce certain flows and certain facilitate learning, for a simple reason, because Git might be the only tool we have in the industry today that nobody disputes, right? We can fight for a long time whether to use, this monitoring tool or that monitoring tool, this and that. But the only tool that I know of that nobody disputes, kind of like, hey, there is no discussion, it's Git. The only tool that every single engineer, no matter whether we're talking about infrastructure, testing, writing Java, this or that everybody uses, unless you're a manager, that's Git, right? So Git did become, in a way, that hub where information is collected one way or another. We are even moving to READMEs instead of Confluence pages, right?
If only that could happen faster.
Yeah. I'm in a process of doing that within our company, so I'm not there yet.
Just anything that gets people off Atlassian is a good thing, in my opinion. But anyway, we don't have to get into that, but sorry to sidetrack you.
No. And so I do think that maybe I'm wrong, maybe I'm too technical and naive, but to me, any flow that is based on Git and will be relatively simple for people to adopt because they're using it no matter what. And that whole idea that everything is an open book, which is basically code itself stored in Git, might be the easiest way to facilitate learning, right? Because if I have some obscure tool that is doing something, right, with some internals, if that's your tool that you're using as infrastructure guy and I'm a JavaScript developer, I'm most likely not going to bother. Why do I? It's not my tool. It's nothing to do with me.
Mm-hmm.
But everybody can go to Git repo to find out information about something. And especially since we are now talking about declarative format, which is easy for everybody to read. I might not be a Kubernetes ninja. I might not understand what is a service mesh. But seeing a change like, hey, I see that you changed something called tag from 57 to 58. Most likely you increase the release there, right? You might not understand the details, but just by looking at YAML, normally you can understand what's going on. No matter whether that's Kubernetes definition or whether that's, I don't know, a pipeline or even Terraform, right? Terraform can be a bit tricky for people to understand, but still, hey, you can somehow follow what the idea is behind it, at least. And it tends to be relatively easy to make some minor changes, right? If you have a huge Terraform definition that does 57,000 different resources in AWS, because that's how much you need, you might not be able to do that yourself. But hey, created a load balancer, this and that. To me, code is the easiest way to learn. And I might be naive. I don't know.
Well, it definitely solves one part of the problem, which is just making it visible, which is one of the hardest parts when it comes to like facilitating and learning and understanding of these complex systems that we all work with. Is like you mentioned it earlier in the conversation, which was point to some person in your, just let's say for the sake of argument here, pick a person in your company or team, ask them to identify all the different source code files that compose the production environment. See if they can do that, right? How much do they get? How much are they missing? Like, what did you not know that they did? If you can see that all of that stuff is present in a Git repo, then you can at least start to grok the whole surface area, right? You gain some awareness of the whole system such that then maybe you can say, this is this. Maybe now I can make a change that you weren't able to before because it was just invisible to you.
And that's one of the reasons why I like that concept we discussed earlier about, let's say, having a repository for production environment, but that repository contains production-specific values and links in a way to repositories that have full definitions, let's say on application level, right? Because that happens to be just the level that is easy to understand to get that picture. And then, yes, if I want to know whether there is an ingress and service and this and that, I go kind of follow the links, almost like, web pages, follow the link and go to that application if I'm really, but most likely I don't care. I just want to see, okay, so those 5 applications are running there. Excellent. That's just the level of information I need at the glance in a way.
Yeah. This also comes back to one other topic that's been coming up a lot on the podcast. I just like it because I really haven't seen it discussed so much, but once I heard about it, it's really important. And the idea of cognitive load, in that you as an engineer or as a person working in these complex systems, you literally only have so much you can fit in your mind at one time. And things that require sufficient mental cognitive load, or, say, imagine yourself as a CPU. If it takes, 90% of your CPU cycles to just process whatever you need to do, then you have no room for anything else. And you don't have room to learn new stuff or investigate things. And like you're coming back to like, you want to be able to operate at a high enough level of abstraction where you can do what you need to do without having to learn about everything that happens behind the scenes. And that level of abstraction will be different for every single person in the team or value stream, wherever they are. Like S3s, like myself, I want to know if there's an ingress. I want to know like all the infrastructure. I need to know all these things. They're really important to the work that I do. But if I'm the person who's writing the CSS or building some, small component in, say, a JavaScript front end or some small thing like that, well, I don't care about any of that stuff, nor should you. I mean, that's the exact opposite thing you want to be taking up your cognitive load on. So the idea of, say, like having everything in Git as some simple declarative format, and then you can, as you say, you can follow the links deeper and deeper and deeper into the system to gain whatever knowledge you have. I think this point is almost self-evident in the fact that all of us who work with Kubernetes, we don't care what goes on behind the API. We just make the API calls and Kubernetes does whatever it does. That's what we care about, the end declared state, not how it gets there. If everybody had to concern themselves with how it got there, oh man, that's too much. It's just too much, And
it also solves, having, in a way, code that acts as your documentation solves, in my head, even bigger problem than the problem of people not learning. And that is a problem of learning something that is not true. Kind of, when you have those Excel sheets and Word documents and wiki pages, and then you tell me, hey, go there and you will find the information that you need. And I just spent an hour reading it only to find out that actually I come back to you and I do not get it. And you take a look and say, yeah, because it's obsolete.
Oh, yeah.
I don't believe in documentation, excluding end user documentation, right? End user documentation, excluding that. Within engineers, I don't believe in documentation. It is not code. It's not accurate. It's not up to date. Never. I never seen a company or a team that keeps their wiki pages up to date all the time. Never.
Talk about a unicorn. Show me an example of a sufficiently complex system that has up-to-date documentation for the developers of that system. I have never seen it. It doesn't happen. I don't know about you, but I will happily take any number of good code comments over anything else, because like when you said learning something that was not true, I felt like I had been just kicked in the stomach, because I just recently had gone through an experience where, I'm like working on something, I'm trying to understand it, and I'm like, okay, this is like, I'm reading all this, like this should make sense. I'm doing it, like this is not working. Why is this not working? And the way that I think about it in my mind is like when you're on the edge of a rabbit hole, like you have to decide to take that like one step and tumble in, or look, stay on the outside and see if you can get somebody to help you. It's really easy to like tumble in, and you come out and you ask somebody like, hey, why isn't this working? Like, oh, the documentation's wrong. You're like, oh God, they're just going all of this time and energy. And the worst part about it though, is not even that. It's that it creates this sort of cognitive dissonance and like, hey, what are you, if I'm reading this, is it actually true? Whereas if you read the code, you're like, this is the code. I know that. But you see a Confluence page last updated a month ago, 2 months ago, it's like, I don't know.
Even in those cases when it's not code, right? There is always a case to write some text. But if you put a comment above, let's say that you have Helm value X equals Y, and then you need to put a comment. If you put a comment above, when I change the behavior of that something, it is infinitely higher change that I will notice and change that comment over there than go to some obscure wiki page in some random place. Simply the statistical possibility of me updating wiki page is lower, no matter how much I want to do that.
Even if you know it's there.
Yeah. Simply, it's already, kind of, it's in my VS Code. It's there. It's README. It's next to the code that I'm changing. I'm more likely to keep it up to date.
Well, and the unfortunate fact of the matter is that those wiki pages tend to be in Confluence, which I don't know about you. I don't like using Confluence. And it's like, oh, I got to go over there and use this editor. And, it's not Markdown. It's some other thing. It's in this other place. And then I didn't expect to be talking about documentation, but like one thing that like always bothered me about this is that you'll have a branch of code and no branch of documentation. Like you can't have like if you're using Confluence, how do you create a potential change to the documentation? You do it after and then update the thing after the code is merged or whatever. How do you synchronize these two different versions of reality in these two different models of what truth actually is? It's like it just doesn't fit. Fundamentally, it's always frustrated me.
I'm much worse than you probably in that time. I'm like a radical Taliban in that sense. No, so I joined a company, CodeFresh, and they asked me, can you write a blog post about this? And I said, sure, why not? Where do you write it? Where do you have your blog? In WordPress. Okay, WordPress. Yeah. Well, I can leave it at now. Kind of, I go there, I see Markdown plugin is not installed. No. I'm not writing anything. What do you mean? No. I just finished writing it. I created a repo for you. It's pushed over there. I can do an extra effort to copy and paste into WordPress. I'm going to do that because I'm a nice guy, but I'm going to copy and paste my Markdown. Now, either you're going to install the plugin for me, or people are going to read something that has hashes and asterisks all over the place.
I know. Oh, man. I haven't laughed like that for a while, but it's so true, though, because you get used to a certain level of quality or workflow that makes it easy enough to do what you need to do. And if you're a radical Taliban like you are and like I am about those things, that if there's a sufficient deviation from that, you will just say, nope, I'm not going to do that because it doesn't make sense. It's not right, in quotes, but there's a certain level of quality that you get from specific workflows. And if that changes, it's like, oh, I can't work like this. It's like you go to a company and they don't have automated testing. Okay, well, you don't have automated testing. Well, yeah, I'll see you later. I'm not even going to bother with this. This is not even worth my time. And I'm not the nice guy who's going to write your test for you. I'm just going to peace out.
Exactly. I think it's very important, at least if you're, not I graduated yesterday type of person, right? If you have certain experience, it is very important that we have certain expectations and demands. And when we join companies, hey, I work like this. I can change how I work, but you need to convince me that changing is for the better.
Right.
I'm not going to change for the worse.
Yeah.
I'm all about change, but only for the better.
Right.
If you want me to, I can change to ASCII doc. I told you if you don't give me a Markdown plugin, I can change to ASCII doc plugin. It's okay as well.
Even textile, we can go that way. It's fine, but just give me give me something like this. Okay. Oh, nice little sidebar there. So much. I always enjoyed talking to people like that, especially when somebody says they're radical about something. I'd love to push on that and find out more about it, because it's like you say, you have to be a radical. You have to be committed to certain things. You have to have the type of principles to succeed. If you're just going to be pointed in one direction because somebody says, new technology, this or whatever, without any kind of critical thinking or analysis behind as to why, with the idea of what is this actually going to improve for me, then you're just wasting your time. I don't want to make lateral moves. I only want to make increases.
Not only that, but if you don't have your opinions, if you don't have your style of working, if you can just be directed if I can just take you and say, move 37 degrees and go, then guess what? I don't need you. I can replace you with a script. Scripts are very good at doing exactly what I want. I don't need that. And guess what? And scripts are cheaper than people. So there is no incentive to use people that will do exactly what I want. I want people who will do things that I don't know that I want. And, that bring something new to the table.
A little chaos engineering for your social aspects. Okay, so I want to ask you one last question before we go regarding what we expect in workflows and what kind of tools we need to succeed. And we talk about these sort of deployment tools, not continuous delivery tools, but things that are actually about rolling out code, making changes to applications, doing these things. We need different deployment strategies like blue-green, canaries, rolling deploys. How, if at all, does Argo's, does it support that? How, or if not, how do you coordinate those type of things using this tool?
So Argo does support it because Argo will simply apply whatever is defined in Git and, YAML file or this and that. And if you use Canary, you're probably going to use something like Argo rollouts, separate project, or maybe Flagger, which again, everything is defined as YAML, right? If it's defined as YAML, ArgoCD will apply the differences.
Okay, I see.
With Canary deployments, we are already getting to the subject of actually difficulties that we are experiencing today with GitOps.
Okay.
And that is that, so if the desired state is in Git, and then the job of tools like ArgoCD is to make sure that the actual state is the same as the desired state. The problems start when your actual state starts changing on its own. Let's say Canary deployments, right? You define, you define in Git and say, I want to have version 57.
Mm-hmm.
ArgoCD applies definition that happens to be, let's say, Argo rollouts, which does Canary deployments. It starts progressing 10%, 20%, 30%. It is monitoring your metrics in Prometheus. And then at one moment, it discovers, hey, there is something wrong. The error rate is too high, for example, and gives it a couple of more tries, and it gives up and say, hey, this is bad. I'm going to roll back to the previous version. So far, so good. That's exactly what we want. But what is happening from that moment on is that the desired state is actually not the state you want anymore. Because your desired state still says version 57, but your Canary deployments rolled back to 56. Whatever you continue doing in Git is likely going to mess that up. Unless you're extremely fast to correct that in Git and do something, you have that drift of the desired state not being what you want and actual state being something else. The same thing can be said for, scaling up and down. There are many things happening today in Kubernetes clusters that are simply happening, right? Without you even knowing that it's happening, right? Like your process, if you're not really watching the process and you don't have notifications, even you as a person will not know that it rolled back.
Yeah.
Right? And now you're a clever guy, you will set up some notifications so you will receive that email, hey, I rolled back, and you say, yeah, that's what you should do. But the whole concept of desire, the actual state, falls apart. I mean, it's a strong word to say falls apart, but that's one of the many things that I think that are unsolved in GitOps. And when I say unsolved without you tweaking the tools that you're using. Of course, you can write the code that fixes everything. Everything can be done, right? But on a tooling perspective, that's one of the many things that we have unsolved. Just like observability, right? I don't have really good ways to observe the desired state. Yes, I can go to Git, and that's great because I can see all the details. But sometimes I just want, give me all the issues that were solved between the current versions of all the applications in staging and the current version in production. I want to know the drift between staging and production before I promote things from staging to production. Tell me that difference, what it means in terms of maybe issues that are solved, maybe all the differences in Git, but without me going through 57 pull requests and so on and so forth, right? I'm just mentioning two of the things. There are many. I'm just pessimist by nature.
Okay. So then I just started thinking about how you would do canaries or how you do blue-green. And you mentioning like the diff between the declared state, the actual state, and then, externalities that change the current state to create the diff. That got me thinking like, well, if you want a canary, well, then make a commit that creates the canary and just let it run. These automated actions are not done below Git. They have to be done at the Git level to maintain that kind of consistency. So instead of having something that did like automated rollback of the canary or like terminated the Kubernetes deployment, you go revert the commit that made the canary or whatever, then the canary would go away, via Argo or whatever this sort of state manager type thing is. So instead of thinking like below the level that should like coordinate this whole process, you have to think of break each non-atomic unit down into individual commits that can be done, step by step in the way that you would think about how do you do continuous delivery when you think of database migrations. You have to do them in a stepwise fashion, like where you add a new column, migrate all the code to use the new column, and then when you're all done, then eventually remove the old column. Like that's like a canary. You might think of it as one whole process, but there's 3 or 4 like distinct steps in that process, which could then map to commits. The same thing for blue-green, one commit to create blue, one commit to create green, one commit to swap them, or whatever. You just have to think of it in that level. Do you think that if you think in that way, then those sort of inconsistencies or quote like problems become less so, or at least they're more accurate in terms of the modeling?
Yeah, it's mostly about tools adopting GitOps principles, right? And this is now coming with one thing that kind of makes me nervous is that adopt for real, not only from marketing perspective. Like, if you go to homepage of Flagger, which is a tool I really, really like. Yeah, I'm a GitOps tool. And then you just roll back by yourself. So I think that hopefully we will be getting there, that those tools are becoming Git aware, and then Flagger or Argo rollouts, when they decide to roll back, hey, push a commit or send a notification to a tool who will push the commit. And if it needs to be done fast and you don't want to wait for the system to synchronize, hey, it's okay to do a workaround. You can roll back immediately after that. I'm not even opposed to canary deployment type of tool rolling back. Just like that millisecond before you roll back yourself, send a push to Git. Just do that.
It's a minor
it's
thing.
It's a millisecond. Exactly.
Yeah.
That doesn't have to even rely on ArgoCD to kind of apply that rollback itself. You can even do it, and it will really depend on how how popular GitOps is. It's always about how popular it is. If it's popular, then companies, open source projects are created, people are interested in it, and then commercial companies are going to build commercial software on top of it. It always depends on how popular something is. And I believe that GitOps is becoming a big thing.
Well, that's something we'll have to watch out for in the next year or two and see what happens. Well, Viktor, it was a lot of fun talking to you, a lot of information exchange here, and definitely some good laughs. And I'm always happy to meet another member of the so-called radical Taliban. Is there anything you would like to leave listeners with before we go?
Go to CodeFresh.io. That's my shameless plug.
So, shameless plug, go to CodeFresh.io and try all this stuff out.
Exactly.
All right, Viktor. Well, thank you so much for coming on the show, and let's keep in touch. Maybe have you back on again sometime.
Definitely.
That wraps up this batch. Visit smallbatches.fm for the show notes. Also find Small Batches FM on Twitter and leave your comments in the thread for this episode. More importantly, subscribe to this podcast for more episodes just like this one. If you enjoyed this episode, then tweet it or post it to your team's Slack or rate this show on iTunes. It all supports the show and helps me produce more Small Batches. Well, I hope to have you back again for the next episode. So until then, happy shipping. Are you feeling stuck trying to level up your skills deploying software? Then apply for my Software Delivery Dojo. My dojo is a 4-week program designed to level up your skills building, deploying, and operating production systems. Each week, participants will go through theoretical and practical exercises led by me designed to hone the skills needed for continuous delivery. I'm offering this dojo at an amazingly affordable price to Small Batches listeners. Spots are limited, so apply now at softwaredeliverydojo.com. Like the sound of Small Batches? This episode was produced by Podsworth Media. That's podsworth.com.